Hi guys, welcome back to the system design interview sessions. Today we're going to talk about Bloom filter. Bloom filter is a simple but important concept in large distributed system design. Before we get into the details, I just want to say all my videos are taken in one shot without cutting or editing afterwards because I'm really enjoy what I'm doing. I'm here to help you and support and coaching everyone to be successful in their system design interviews. And so that I think that's the most important thing. I want to share the content, but more importantly, to encourage everyone to book one-on-one sessions with me because I do realize there are like many millions of content out there online about what you can learn, either in details or high level about different concept, different technology, different component. But the most important thing is about like you, what you master, what you can present in the system design interview, and how can you improve like significantly or to the next level 1 week or 2 weeks before your upcoming interview. That is the most important thing. Maybe you have like master all the technical details. You just need to have like the right flow, right sort of train and how you present yourself in the system design. Or maybe like you're already a good presenter. You just need to know like what level of details you need, like for different companies. Is it a phone company, large enterprise, startup, scale up? There's difference. So you don't want to be feeling lost during your interview preparation. That's the main focus for me. Like what you can get from me is not really, I think maybe like my unique selling point is not like how familiar I am aware about the big systems, how like detailed knowledge. I think I cannot compete with like generative AI, but what I feel like most valuable thing I can contribute to your success is just tailored advice about like I can provide constructive feedback, which is the why people always feel interview is difficult because like you don't have like feedback. Even you may have like done 10, 20, or 50 interviews, but normally there's like no feedback. Even if you are successful, people don't talk about like how you behave in the interview, what is good, what is bad. Even though some companies do provide, but they keep it at a high level without tailored for your growth or further development. So that's what I would like to share before we get into the details. Okay, back to Bloom filter. Like I said, it's a simple but important concept in system design. They are widely used in high performance, large scale systems where faster lookup and space efficiency are required. It's as the name suggested, you can see also, so what's the problem to solve? Its name suggested, it provides a filter mechanism to see if a key exists in a dataset or not. So it removes overhead for data seek directly, especially for expensive queries if they do not exist. So it reduces latency with a large volume of data. Thinking about like you have database either sharded or not, or like object file storage, and even like in some case in memory storage, you want to look for a key. So instead of going directly, you go with Bloom filter to see, okay, does the key exist in this shard, in this partition, or in this like a caching segment. So it is super fast. It's manipulated at a bit level, and in most systems, it provides like by default. We will go into the detail to see like why it is fast and efficient in a few minutes. But I think some generic use case, what I said like before looking for some data, I think that's the main purpose. So you can see it's for database or different data storage for web crawling, search engine, content index, dedupe, network security, fraud detection, etc. So it's super helpful. And then what is Bloom filter in general? So it has a few important characters. It's a bit array-based probabilistic data structure that uses multiple hash functions to store and check for membership. So some key concept like hash function, it uses hash function. Sometimes one, sometimes three. It's one of the parameters you can fine tune based on your specific case. It achieves O1 efficiency, and of course, it's a bit array. It operates on bit level in memory. And as note, the false negative is not possible because false negative, yeah, it means if it size doesn't exist in this data set, it's definitely not. And then there is a possibility of false positive, which means even if it size, hey, it is here, there's a possibility it is not. So there are some trade-off here we can see later on about how you can configure and fine-tune based on the use case. What is more important? Space efficiency, size, number of elements stored, all the false positive possibility, how tolerant you are with that. And so some details I prepared, something like this. So how to build the beta array. As we said, there could be one or multiple hash functions with any key exist. It builds the hash. So for example, hash function one could be SHA-256, could be MD5, it could be any specific purpose hash functions. In the system design interview, I don't think you need to master those level of details. But if you are interested, you can go to Google this or use ChatGPT or Grok to learn about the details. And also there are multiple mechanisms to implement Bloom filter. But unless you are applying for a role that really has strong requirement for this, you won't need that. Some basic concept about like, hey, it has multiple hash function. It builds the hash on the key and it provides the result. Maybe like say let's 5 and 11 for hash function 2, 6 for hash function 3. So as we said, originally the beta array, the default value for any position is 0. And in production environment, it could be hundreds of thousands or even billions of bit in this. Again, it depends on the use case and the data volume. And then after the hash is built, it will change the value at the position into 1. So in this case, 5, 6, and 11 will be updated to 1, 5, 6, 11. Okay. And then it's the same for like Apple and Orange and for all the other keys. Like could be millions, hundreds of thousands. And I'm just simplified here like to explain the concept. And so let's say for Orange, the hash value for this at the result is 279. So let's do that. Those value from 0 to 1, 2, 7, 9. Okay. So that's how we build the beta array with existing keys. And then, like we said, we can filter. We want to check if cherry exists in this storage. So we have Bloom filter here, and in the backend, it will be like date storage. Actual date. Normally they stay on the same server. So a request for a key cherry comes in, we build the hash 3 as normal as what we did for the existing keys. And then as a result, we see 357. So let's see 3, 5, 7. All right. So as you can see, 5 and 7 has a existing with bit array with bit 1 and 3 doesn't. And how it works is like if any of the hash value doesn't have a value, a mapping value on the bit array, it means this key doesn't exist in this Bloom filter. So you don't need to go query the actual data storage because it is guaranteed cherry doesn't belong to this data set. And then they could be moving on to check the next data set or just reply to the client, hey, the key doesn't exist. I do not have any result. without looking to query the data storage, could it be database, could it be cache, could be file object. So you don't have to look into that. You can do a very quick search in the Bloom filter to be certain like the key doesn't exist. We mentioned about like false positive. So there's a case, for example, if another key we need to check. Like plum. And goes through all this, produce some result. All the hash function and all the hash functions run in parallel, as you can imagine, for extreme efficiency. Let's just imagine. So for example, as a result, it has 2, 6, 11. Let's say the key doesn't exist in the storage, but from the cache value, we can see it's 2, 6, 11. It takes all the hash value on the bit array is represented by 1. So there is a possibility the key belongs to the data storage. So that's why like now we need to go check the data storage to find the value, and there is a possibility normally between 0.1 or 0.01% possibilities based on like how we set all these parameters. But as you can see, it's just add a layer add a filter to prevent unnecessary database or data queries. So as simple as that. Some important concept about parameters, definitely about bit array size. Normally you can store like hundreds of thousand base or even millions, depends on the data volume, number of hash functions. That affects, of course, lookup and insertion time. Normally it's between 1 to 3. With one hash functions, you can add something like the append the value with the number between 0, 1, and 2. So in theory, you're using one function, but still get 3 results. But normally industry-wide, you can have like 3 hash functions. And of course, you can have more if it's necessary. And of course, number of elements presented, estimated X number of elements to store. And then calculate the false positive probability. There are some mathematics formula you can use or calculate the array size. And you can see the P is the possibility, and it's the number of elements, and I is the bit array size. And of course, you can try to define which first you have a certain false positive probability, and then you can figure out the array size with a certain elements. So you can make changes accordingly. So in general, that is how Bloom filter works. And just I think you need to remember the main purpose for it, just to reduce the overhead to query the database if the key doesn't exist here. It will filter out or provide a mechanism to have a quick decision made, the key exists in this shard, in this segment or not. So that's basically it. Hopefully you have a good understanding about this now. And if you want the code implementation in C#, let me know in the comment. I can provide it. It's basically simple. All the parameters are here. You have like a array, and then you have like hash functions to calculate the hash. And then when you check, you do the same. You hash and find like if any bit is missing, then just straight away you return like the false. Great. Thank you guys for watching. Let me know if you have any questions or you would like to book one-on-one sessions to help you prepare your upcoming system design interviews. Thank you. See you next time.